Bismillahirrahmanirrahim. So this is our third lecture of statistics and probability theory, and the course code is MTH262. In previous lectures, we have discussed presentation of data. In presentation of data, we are concerned about that how would we present the data. There are three methods to represent the data. One is textual method, which is particularly used for the ungrouped representation, stem and leaf plot. And the second one is tabular representation, in which we make frequency distribution of the data, which we have discussed in the previous part. And now the third one is that we represent the data in the form of graphs and diagrams. So we will continue with the topic presentation of data, and in this part we will discuss that how can we represent our data with the help of the diagrams or graphs. So the very first one is histogram. What is histogram? It is a representation of a frequency distribution by means of rectangles whose width represent class intervals and whose areas are proportional to the corresponding frequencies. You are familiar with these terms, class intervals, which we have discussed in previous part, and frequencies, this is also discussed. And now, definition of the histogram. So this is the way histograms look alike, a graphical representation of the distribution of numerical data. So this is basically the graphical distribution, and we often confuse it with a bar chart. Very useful technique, and it is a statistical technique, of course, to understand the spread of data for our process. So as you can see that we have x-axis, y-axis, and we have rectangles. And one thing to concentrate that rectangles are connected with each other. There is no gap between the rectangles, and this spread usually show the spread of the data. That is the peak of your data, this is the lowest point, and this is the highest point. So if you see the spread, it would be like this. That it is increasing, and this is the peak point. And now again there's one peak in the data, and this is the whole spread of the data. Parts of histogram, if you concentrate on it, like we have discussed in previous lecture, we have table, and table have different parts like title, body of the table, categories, column headers. Likewise, we have parts of histogram. So this very first part, days of operation. This is one particular example of some data, and we have taken its histogram. Days of operation prior to failure for an HF receiver. Number 1. So this one is the title of the data. So this is number 2. Number 2 is horizontal axis. So basically this one is the x-axis, and obviously this one is the y-axis. Number 5, this is called the legend. Mean time between failure in days for R1051 HF receiver, data taken at schema Pearl Harbor 15 May to 15 July 94. This is basically representing that from where the data has been taken and what is the description of the data. So these are some particular, and number 3 are the bars, which represents the height represents the frequency in particular class. On x-axis, we represent the classes. This one is lower class limit and upper class limit, likewise. So it's better to use class boundaries here in x-axis and frequency on the y-axis. Now, we have discussed in this example in the previous part that there was a consignment in which we have taken the 60 apples whose weight were recorded, and these were the weights. We constructed the frequency distribution for this particular data. So now we will make the histogram for this data. As you are familiar with this table, we have discussed this, that these are the class boundaries, these are the class marks, and these are the tally marks, and this is the frequency of the data of each. This is the way to construct the histogram. We will take frequencies at the y-axis and class marks at x. You can take class boundaries as well. So here we will take midpoint of the class or class mark. Now we will set the scale here. For the frequency, as the minimum frequency is 4 and maximum frequency is 17. So this is the starting point 0. We will take here 2, 4, 6. Keep in mind to take the distance between 4, 6, 2, 4, same distance as you are setting the scale. This would be 8. This would be 10. This would be 12. This would be 14. This would be 16. And the last one will be 8. Now here we will mark the class mark. Let's say this is the first class mark, which is the midpoint of the class 4.5 and 4.5. This one is 74.5, and here we have the first class mark 74.5. As this is the midpoint of the class, so here we will have, let's change the color. So here we will have the lower class boundary of the particular class and upper class boundary of the particular class, and the height of this class is number of units falling in the class is 9, which would be somewhere here. So if we construct a rectangle here, it's like this. So this is the class with class boundary 64.5 and 84.5, which green lines are representing the lower class boundary and upper class boundary, and this blue rectangle is representing the height of the class, which is the frequency, and which is 9. The next class is 84.5 to 104.5, and class mark is 94.5. Let's suppose this is the response of the class, and it is 94.5, and the upper class boundary would be in green color, and this is the lower class boundary would be 4.5, which is this one, and upper class boundary will be 104.5, and we will represent the rectangle with blue color, and the frequency is 10. Here we have 10. It will come here, and the frequency the angle is the frequency of this particular class, and frequency is 10. So the next class is 104.5 to 124.5, and its class mark is 114.5, and it would be here 114.5, and the lower class boundary is 104.5, and upper class boundary is 124.5, which is somewhere here, and the height is representing the frequency, which is again 17, and 17 would be somewhere here between 16 and 18, and if I go in this way, so this is the point. I will construct our experiment here, and this would be in here. Keep in mind that width of the rectangle should be same as I'm constructing it without the help of any ruler or scale, so there could be some difference. But when you construct it, please keep in mind that width of each rectangle is the same. If we have same class width of each class, and their frequency is 17. The next class is between 124.5 and 134.5, and class mark is 134.5. So the class mark is 134.5, and it would be somewhere here 134, 134.5, and the upper class boundary is 144.5. So this green line represents the 133.5, and the corresponding frequency is again 10. So as we know that the blue color represents the rectangle, and this would be behind 10. So now the next class is between 144.5 and 154.5, and class mark is 154.5, and here we will have 154.5 sitting in front of the class, and this one is 1, uh, 164.5. And the upper class boundary is 164.5, which represents the green color. I'm not marking the class boundary. I'm not meaning it. I'm just changing the color. The green colors are representing the class boundary, and these are in red as not marked. So the frequency of this particular class is 5, and the class size of the class between 4 and 6. So let's go to the 6. And the next one is 174.5. It would be somewhere here. And the upper class boundary is 184.5, and I'm representing it with green color. And rectangle height there would be 4, and it's in blue color, and 4 is here, which should be scheduled in this way. So this is 4. And the last class is 184.5 to 204.5, and it is 194.5. It would be somewhere here. And 4.5. And the class boundary, upper class boundary will be 204.5, which is somewhere here. And the frequency is 5. Again, this is mirror to this, height is this, and this is representing the um, the rectangle representing the height, height representing the frequency, which is again 5. So these are class boundary and class mass apple, and with at y-axis we have the frequency, and the rectangles are representing the total frequency in each class. This is the first class, 64.5 to 4.5, and it has frequency 9. This is the second class, and it has frequency 7. That means the number of minutes falling in the sector is 10. So this is the total spread of the data, and you can see that this class with class mass 114.5 and lower class boundary 104.5 and upper class boundary 124.5 have the maximum units in this class, which are 17. So this is the way of representing the data in the form. This is the latest I see Instagram and this series